So this is a tricky AP problem here. Let's try see if we can do it. The functions f and h are twice differentiable. So whenever you see that twice differentiable, that means, so they're saying f and h are both twice differentiable. So f is differentiable, and then f prime is differentiable. And remember, something is differentiable means it's smooth, and to be smooth, it also has to be continuous. So differentiability implies continuity. So we're saying that both f and f prime are smooth and continuous. That's what we're saying. And we're saying the same about h and h prime. Okay, now they tell us also that h of 2 is equal to 4. That means if you look on the graph of h, if you're at x is equal to 2, then y is equal to 4. We know there's 1 point on the graph of h. Now the function h satisfies this equation. H of x is equal to x squared minus 4 over 1 minus f of x cubed, right, for x not equal to 2. And the limit, because at x equals 2, we know h of 2 is 4. Now, the limit of h can be evaluated using L'Hopital's rule. And we're asked to use this limit of h at 2 to find f of 2 and f prime of 2. So it sounds like a crazy bunch of gobbledygook until you think about it step by step. So first of all, let's use this fact that the limit can be evaluated. The limit of this function as x approaches 2 can be evaluated using L'Hopital's rule, right? That means that the top and the bottom must be going to either 0 over 0 or infinity over infinity. So the top, when x approaches 2, is clearly going to 0. So that must mean then the bottom, as x approaches 2, is also going to 0, right? Now, this bottom, 1 minus f of x cubed, f is continuous. And so whenever a function is continuous, we can put this arrow number in and evaluate the limit that way. So that means that we're really saying that 1 minus f of 2 cubed is equal to 0. That must mean f of 2 cubed is equal to 1, or f of 2 is equal to 1. Okay, so we already found this. That's step 1. Okay, now step 2 says we need to find f prime of 2, right? So we know that L'Hopital's rule can be applied for this limit. That's one thing we know. We also know that the function h of 2 is 4, right? So now this is the limit that we're after. And we know that we can apply L'Hopital's rule for that. But since this function is continuous, this limit is h of 2. So we know the limit is 4. And we know we can apply L'Hopital's rule. So let's apply L'Hopital's rule. We get 2x on top. And now on the bottom, we get 1 minus 3f of x squared times f prime of x. That's applying chain rule. And we're doing this limit as x approaches 2. And we know this is equal to 4. So now, again, we're going to have to use continuity, right? We know that f is continuous and f prime is continuous, so we can plug this arrow number in and we get 4 over 1 minus 3 f of 2 squared, which is 1, times f prime of 2 is equal to 4. So that means that f prime of 2 is equal to -1/3.